Well, I'm very happy to introduce next talk here at EMF. I think we're still about the same time. So it's PJ Evans talking about boiling Nemo and Internet of Things. So there you go, thank you.
Okay, I'm just waiting for my screen. Mr. Nice AV people. Are we all enjoying EMF so far? Cool. It'll be nice when it's finished. No, seriously, kudos to John C. and the team for doing an exceptional job in exceptional circumstances. As part of the content team, I've been watching what's been going on in the background, and if you were at the opening talk, John T. didn't tell the half of it. He was very, very polite about some people who should not be being very polite too. But we're just trying to work out how the screen works. It's fun. Talk amongst yourselves. Oh, I could do a plug, actually. I could do a plug. One of the things me and my family are doing here is running the film festival. And yay! And we've got, oh, yeah, there we go. Well, I've started now, so I'm going to finish. Yep, slightly distracting slide. Pixar were not consulted. So we're running the film festival. Tonight we've got a world premiere of Tent Man, a 30-minute feature that was actually made here at EMF in 2014 and 2016. I know it's the world premiere because I haven't seen it yet. I'm told it's very good. And then we're showing Coraline, possibly the scariest animated feature ever made. It's absolutely brilliant. From Neil Gaiman and the director Henry Selick, who directed Nightmare Before Elm Street, Nightmare Before Christmas. That would be a very different experience. But of course, on Saturday night, we've got our big presentation, which is Hackers, with Jake Davis, aka Topiary, in attendance, and the director Ian Softly answering your questions afterwards. It's going to be amazing. So, I better get on with the talk. Boiling Nemo, adventures or misadventures in the Internet of Things. So, a bit about myself. My name's PJ Evans. For EMF camp purposes, I write for this magazine. This is the new issue that's just come out. It's another little slight plug for you. In this one, I've built something to annoy my teenage son, which is this klaxon. So he's always there playing his games, headphones on. So you can build this with a Raspberry Pi and quite a cheap little industrial light, and I can send signals to him from a mobile phone. If he gets really annoying and doesn't come down for his dinner when I want him to, it sets off the most ear-piercing screech you've ever heard. That gets through to him. But anyway, on with the show. I've been building Internet of Things for quite a while now, and I want to tell you a bit about my experiences and hopefully encourage you to go out and start building your own things. The story starts with this device here. It's called a canary. Anyone ever heard of one? No? Probably not surprising, really. Now, my boss at the time bought one of these and came in and said, "Oh, PJ, this is brilliant. It actually looks quite nice. You know, you could put it on your mantelpiece or on a table somewhere in your house, and it's got a camera in it and a motion detector. And when someone moves around, it takes a little video. So if someone breaks into your house, it takes a video of them." And I said, "That's brilliant. Where's the SD card slot?" He said, "It hasn't got one." "Oh, right, so it's USB. You plug it in, and you take the video off the device, so you've got a video file on your computer that you can give to the police." He said, "No." And I said, "Well, how'd you get to it then?" He said, "Well, you connect to the cloud." My alarm bell started going off. I said, "The cloud, huh? Oh, right, so okay, they're trying to do it so it's easy to use. You log into your account on there, and you download the video." And he said, "No." "No? Only if you pay a subscription. So you've dropped about 200 quid on this device, and then, if you actually want to download the videos, you've got to pay another £25 a year. Since he got the device, that's changed now, and you could be paying up to £25 a month to get access to your own videos. Now, things like this is why, you know, here's the cloud and here's me. I am suspicious of the cloud. I don't like it very much because it's not the cloud, it's other people's computers. So I thought it would be a bit more fun to build my own things. Now, I didn't really get anywhere until I had a problem with this. My fish tank, 190-litre tank, filled with tropical fish. I absolutely love it. And it sits there in our dining room. I come down for breakfast one morning, and my son's there, and my wife's there. And I walk in, good morning, everyone, and my wife gives me that look. Now, if anyone's been in any kind of long-term relationship, they know this look, especially if you've got kids. The look says, do not say a word. Which was fine, because I didn't have the slightest idea what she was talking about. So I didn't say a word. And she kept looking at me, saying, what? I haven't got a clue. And this went on, and breakfast finished. My son went off to school, and my wife said to me, what happened? And I said, I don't know. And she looked over to the fish tank, which was a bit suspicious because of the absence of fish. There weren't any. Where'd they go? We opened up the top, and there they all were. About 60 fish, beautifully poached. We had boiled Nemo. What had happened was that the thermistor that controls the heater had broken. And for some reason, its default state was to leave the heater on. And over a number of days, the temperature at the tank had risen and risen till the fish couldn't take it anymore. So I was like, right, can't have this happening again. I mean, we lost, seriously, we can joke aside, but we lost fish that were over 5 years old. It was actually, at the time, quite upsetting. So I went to work. Can I buy something that measures the temperature and lets me know if anything's awry? And the answer is no. No one's got something on the market yet. So I decided to build my own. And I thought I'd use one of these. I love these. Raspberry Pis. I even write for a magazine about them. And this is the Pi Zero. And the best bit about Pi Zero is this bit, the GPIO. A device, this is a computer you can buy from as little as £9, £12 if you want Wi-Fi on it as well. And then you can connect all kinds of devices to that circuit board. And there is tons of documentation out there and tutorials. So even the absolute beginner can get their head around what's going on. So I took one of those, and I thought, right, oh, blimey, something got louder. I thought, right, I need something that's going to measure temperature, something accurate to within, let's say, 1,000th of a degree Celsius. Something like that's going to be really, really expensive, isn't it? Went on Amazon, nah, £1.50, and free delivery. Awesome, I bought two. I've got the other one here. There you go. Cheap as chips. Incredibly accurate for Mister, and it's waterproof. And it just has 3 wires at the end, power, ground, and data. Again, tons of tutorials and information about how to get this thing wired up. So I started a plan. Now, I should explain. I was in a bit of a hurry putting this presentation together, and I'm no good with clip art. So what I did is I went to Keynote, and they have a little search box for the clip art. So I just typed in what I wanted and took whatever it gave me. So here's my tank. Here's my fish in the tank. And here is my thermistor that I've put in there. So they're all in the tank, and then they didn't have a raspberry, so it's connected to my strawberry Pi. That's reading every 15 seconds and taking a reading of the temperature. It then sends that, and believe it or not, this is what I got for server, to a server in a cloud. Yeah? Okay, so that's my network diagram so far. Here's what it actually looks like, wired up with a Raspberry Pi. Incredibly simple, only need one resistor as an extra component to get it up and testing. And this is what the end result was. This is a website I built where you can see throughout the day what the temperatures are. And the 2 red lines are the high level and the low level that it's safe to be in. And as you can see, once I got it up and running, it was working perfectly well. So I thought, project over. The only thing is, how's it going to tell me? Well, I got it to send me an email. That was straightforward enough if it went out of range. But if I'm on my phone, I'm going to need to know about it. So there's me on the phone. So I went with pushover. Now, that's actually a quite good app because there's no subscription model for you. You pay for the app once, and then it gives you an email to notification gateway. So I can get things like that. That's when it's the actual thing crashed, which it did frequently at first. It tells me I've not had any reports in on the temperature. Go and have a look. So, project done, all happy. Until I went on holiday to Scotland. Now, if you've read the blurb for this talk, I did say there was a Scottish toilet emergency, and this is it. This is one of my favourite places in the world. This is the Cairngorm Hotel. Absolutely lovely bar up in Aviemore in the Highlands of Scotland. And my wife and I and my son, were sitting there, quiet drink, enjoying the atmosphere. And I suddenly got the call of nature. And I thought there was going to be some time, so I took my phone. Now, the phone had been off. So wandered off to the toilet, sat down, looked at the phone, and that stared back at me. Oh dear. And when I looked at the website, it was something along the lines of that. It had actually happened again. This is about 6 months on from when the project was finished. The thermistor had broken again, and the heater was heating everything up. But there's a problem, because there's my network diagram, but it doesn't account for me being on a toilet in the Highlands of Scotland. The plug socket is 600 miles away. Now, in this instance, I was quite lucky because we had someone looking after our cat, and I was able to send them a text message saying, can you nip round, just unplug the heater, it'll be fine. And we didn't lose any fish from that incident. But it did realize that I had a problem if that happened again and someone wasn't coming round to the house on a regular basis. So I got one of these. You've probably seen these all over the place, little radio-based plug sockets, switch things on and off with a little remote. The Energini one is particularly good because A, it's quite cheap, it's only about £12 for a pack of 3, but also because Energini make this. This is a little add-on for the Raspberry Pi, a little hat, as they call them, and they give you the software to actually send those transmissions from a Raspberry Pi. So what I was now able to do is put that on the Raspberry Pi, and then complete my network diagram. Rather than being able to do this, I can actually get and cut the temperature and cool my fish down. I can actually do that. So when the temperature goes out of range, the Raspberry Pi itself can switch off the heater. So I've got a nice closed loop system there. I decided to take it a step further and get into microcontrollers. Now, these things are incredible because a Raspberry Pi is a very powerful object, and I was doing a very simple job. So it didn't really require the horsepower. I didn't really want to have to maintain the operating system. So I started looking at microcontrollers. This is based on the very popular ESP8266 Wi-Fi and sort of Arduino compatible chip. And it also runs a variant of Python. So it's quite easy to code. And so it's very, very tiny as well. It's only about that big. And I thought, God, something like that's going to be really expensive, isn't it? It's a premium piece of technology there in a tiny little size. Now it's £3.50. Cheap as anything. It's an absolute bargain. So there's a new wire up of the thermistor using the microcontroller. Only about 20 lines of Python to make the whole thing work. And that's been sitting in its little box ever since. But I couldn't really put a breadboard like that near a fish tank. It's a bit wet. So I'd drawn everything out in a freeware program or an open source program called Fritzing, which you can use for designing circuits. And you can draw it out as if it was physically there, which is what I did there, and then you can go to another screen and it will make a PCB layout for you that matches the circuit. This is obviously with a few tweaks, but that's what I basically come up with. I thought I could make my own PCB. I'd never done anything like that before. But I was like, okay, you've designed it for me, that's all cool and brilliant, but how do I actually make it? And I looked at the bottom of the screen and it said fabricate. That's impressive. So I pressed it and looked at my printer, hopefully, but nothing happened. What actually happened was it went to Germany. And in Germany, they made the circuit and then posted off to me about 2 weeks later, my circuit turned up. And they just had a little socket, so I could just plug in the little ESP8266, wire it all up, pop that in a little box to keep it dry, and now my fish are monitored constantly by it. So you start with these little ideas and you keep reiterating and building them up. I then started to get carried away and started over-engineering things. So next up was a doorbell. Now this is a speaker for a wireless doorbell. The circuitry is pretty locked down and very, very tiny. It's hard to muck around with. But what you can do with those 8266s is you can read analog. So what you just do is you hook it up to the speaker. And when the speaker activates, you see a drop in voltage. So you know the doorbell's ringing. So it also can power it as well. So plug it in USB and it will power the doorbell, remote doorbell as well. And now I get a ding dong, which means I can wear my noise cancelling headphones and not miss the courier. It's brilliant. And now this is my garage door. I hope you all realise that. So, I am terrible with my garage door. It's an electric one. It goes up and down on its own, and I am forever leaving it open. And my very good neighbour keeps dropping me a text message saying, "You've left your garage door open again." So I thought, okay, can I build something that will help me with that? Now, what we used is reed switches. Now, these are incredibly cheap. You can buy 5 for £5. And what you've got on one side is a magnetically driven reed switch. It just switches on and off. On the other side, which is dropped on the floor, all you've got is a little magnet. And they both got little sticky pads on the back, and you put one with the magnet on the frame or the door frame, or the door itself, and you put the other one with the wires on the frame outside next to it. And then when they move away from each other, the state changes, and you can read that in with your microcontroller or Raspberry Pi. So I built one up and hooked it up to a Raspberry Pi, which you can see there, and hooked it up to the garage door. And now my garage door has an API. You can talk to it. It actually lives up here. This is next to my solar panel inverter, which talks Bluetooth for safety reasons. They don't really, it's got 400 odd volts running through it, DC. They don't really want you plugging things into it. So the Raspberry Pi sits there and chats Bluetooth to it, getting stats out and uploading them. So it now does that and looks after the garage door as well. It also chats Bluetooth from a Nissan Leaf, which is parked outside. So we can get stats and information from there. So it's quite a busy little thing. Now, I realized at this point with the garage door that I was getting into another aspect of the Internet of Things that people talk about, and that's big data. I wanted that to be a real good big slide, never mind. Yeah, big data, so I've got big data now on my garage door. So let's have a look at it. So here's a typical day. The 21st of September last year. I didn't say there were 5 door opening events, all around 30 to 50 seconds. What I've learned from that is it takes me an average of 45 seconds to get a bottle of wine from the fridge. It's good to know. But when I compare it with the next day, what's happening here? It's about 600 odd seconds it was open for. Why? Because I left the bloody garage door open again. But thankfully, it told me, not my neighbour, so I was able to go out and do that. And then what happened? I did it again later on. But I caught it a bit quicker that time. Now, this one's slightly more complicated, but it does tell an interesting story. These data points, the axis, by the way, is 7 o'clock at the bottom, AM, to 7:40 AM. Between these 2 times, my son leaves for school, and he gets his bike out of the garage, so he opens and closes the garage door. So these data points are at what time between 7 and 7:40 he did that. What we can see here is he is slowly getting later and later for school. So he can nip that right, and he's looking at me now. So you see, big data, very important. The latest project I've done is a rain sensor. Again, these rain sensors are insanely cheap. They're about £1 each. And they're very, very simple, just 2 lines. If it's raining, it sends some information. If it's not raining, it doesn't send some information. And you can hook it up to a Raspberry Pi, no components required, and there's plenty of code out there that you can Google to actually read the things in. So what I've done, as you can see here, is I used 2 sensors to get a bit more surface area, made a little 3D printed case to hold them in place, and then used a food container to give some water resistance. Then you've got a battery and the microcontroller inside there that is just constantly reading it. And it's got a Wi-Fi connection so it can send an alert if it rains. Why have I built this? Because if you've had yourself or your wife screech, "Rain!" when the laundry's out, you know you're going to come down some very wet laundry. So what you do is you put the laundry out, you just stick that out in the patio, and just leave it there, and it will alert us if it rains. What the? Backblaze don't understand the do not disturb mode. Naughty. Oh, sorry about this. So, sorry about that. What we've ended up is this is my network diagram now. It's all getting a bit out of control, and of course I want to be able to access that data in the cloud, on my laptop, or on my phone, on a toilet in the Highlands of Scotland. So it's all got a bit much. So I did what every good programming engineer, software engineer does, and writes their own messaging protocol. And I've called that WASIT, and you can actually have a look at it now at wasit.org, which is basically just a simple way in Python of getting devices to send and relay messages to each other. It's very much in an alpha state, but have a look, see what you think. It's all on GitHub. So there we are, in the Highlands of Scotland. Now, we're going to do something very, very stupid, especially EMF, and try a live demo. So here's our lovely day, which we've got currently now. I'm not just looking at my phone because I'm bored of giving this talk. That's not true at all. I'm just setting it up. Make sure it's nice and loud. Take it out of Do Not Disturb. Right, here's my phone. Here is my rain detector. And oh dear, our lovely sunny day has turned into a thunderstorm. Now, we're going to use some like high-tech special effects to recreate that weather environment. There you go. So I don't know if you can see this, but what I'm going to do is I'm going to spray this right next to the electricity. No, I'm not going to do that. That's really stupid. Right, so it's going to start raining on this device. And nothing happens. It has actually activated and said, oh, it's raining, but whether it's got an actual connection, oh, there you go, it's raining. Yes! So there you go, and I don't have to pay a damn subscription to anybody. So, if you've been affected by any of the issues raised in this presentation, here's some of the places you should check out for some more inspiration ideas to build your own Internet of Things. And there's some URLs as well. Thanks very much for coming along. If you've got time for any questions, I don't know where on earth the schedule is now, but yeah, we're saying yes to questions. So if anyone's got any questions, please fire away. Do we have the ball thing? Oh, there it is. Right, that gentleman over there, I think. The gentleman, lady, can't see. I'm blinded. Woo.
Hello.
I thought it might be you.
What a wonderful talk. No, it was so much fun. The bit of software where you hit fabricate and it magically came from Germany, how much did it cost to sort of print and then ship out?
Yeah, because it's bespoke, it's not particularly cheap. It was about £30.
That's not bad.
Yeah, it's all right. And yeah, I was quite taken aback of how seamless the process was. They kept sending me updates saying, right, you know, we're doing a run on this day. You'll have it a few days later. So yeah, I was quite impressed with it.
Cool, thanks.
Okay. By the way, I'm just going to say that gentleman's name's Terence. If you enjoyed this talk, or if you didn't enjoy this talk, you might enjoy his talk, which is called The Connected House of Horrors, which is on Sunday.
Sunday at 12:40, right here.
Yeah. So he's done something a bit different from me with the Internet of Things, but it's a great talk. Anyone else?
Hi there.
Hi.
Have you you noticed you wrote your own protocol? What's it? Have you looked at MQTT at all? Because that operates in a similar manner.
Yes, absolutely. Now this is the problem. This is not what was it solves, because there are many different ways of the devices talking to each other. HTTP, MQTT, which for those who don't know is a really data efficient way. So when you've got big data things, like let's say in Milton Keynes they monitor all the parking spaces, so 10,000 odd parking spaces, you're going to want to conserve your bandwidth. So MQTT is designed for that kind of application. That's not the problem it solves. In fact, WASIT is going to support MQTT as a delivery protocol. The problem was there was no standard way that I could find for a device that's never known about another device to talk to each other. So it's more of a schema than anything else. So any device I build is going to obey these simple rules for how it delivers the data, and that means that anything I build in the future will be able to talk to it natively.
Cool.
Whether it's, I don't really care how it does it, by carrier, pigeon, MQTT, HTTP, whatever it likes to do it.
Thanks.
Yeah. Anyone else? Oh, this gentleman here.
Oh, this is going to be good.
I love this ball thing, it's fantastic. Oh, not bad. Not bad at all. Yeah, round of applause for that.
Hello?
Hello.
You mentioned they were tropical fish.
Yes.
What happens if the fish tank gets too cold?
But they're actually quite hardy with the cold. They don't mind it that much. It's not good for them. It's much better than being too hot. In fact, there's a couple of fish in there called danios that did actually survive the extinction level event, as we call it, because they don't mind the temperature dropping, or indeed increasing. They're quite hardy. But yeah, it depends on the fish, but always better too cold than too hot. But 21 to 26 for the record. Okay, cool. Is that everything? Well, thanks so much for coming along, listen to me ramble on, and I hope you have a great EMF. Thank you very much. Thank you.